Good day, students. Today we are considering an important topic, which is projectile motion. Projectile motion deals with when you throw an object in a parabolic way or you throw it in a curved path, and it is defined as a path taken by an object or particle that is thrown indirectly towards the Earth's atmosphere, and it follows a curved path, and the acceleration is constant when an object moves due to the gravitational force. It follows a constant acceleration as the object moves. Examples of projectile motion is when you throw a ball and when you fire a bullet, and a boat that is moving in the river, it moves in a parabolic way. And also we have in a case where this earth moves around the sun. And also we have another thing we want to discuss about, which is time of flight. Time of flight is the time taken for an object to move from a particular point and return to the point of the projection. Let's say projectile motion is defined as a path taken by a particle or object that is thrown indirectly toward the Earth's atmosphere. The object then moves in a curved path and it faces constant acceleration toward the center of the Earth due to the gravitational forces. Example are throwing a ball, the motion of the shell fired by a gun, the motion of a boat in the river, the motion of the Earth around the sun. Let's say this is the way the object moves, get to this point. This is the highest level, the motion, comes back to the point where the other point. Now let's see the time of flight is the time required for a projectile to return to the same level, from which it was projected. This is the same level it is required for a projectile to return to the same level from which it was projected. This is where the object is before you fire the gun or your catapult. When you want to kill a bird, it forms a parabolic form, and from the point where you fire the gun to the point where the bullet lands is the range, and this is the height. And we're going to derive an expression for the time of flight. That's the next thing we are going to do. Now we want to derive an expression for the time of flight. What we mean by time of flight is the time taken for an object to leave a particular point of projection and return back to the same level in which it was projected. We want to know the time it takes to reach the maximum height and also the time of flight, that is total time of flight. When you hear time of flight, it means that the time taken for an object to move from the initial to the end of motion. Now, let's see. The vertical component, Vy, vertical component is horizontal component. Horizontal component is vertical component. So Vy, this is hypotenuse. Let's use U to represent that. This is Vy. Don't forget this is Vy also, and this one is Vx. This opposite, and this adjacent. We want to know the vertical component. We talk about Vy and also Vx. The expression for both of them. Now let's see for this one we have Sukatua. This means sine theta because opposite over hypotenuse and also cos theta equals adjacent over hypotenuse, and then we have tan theta equals opposite over adjacent. Now in this case, we're going to look for the expression for this, which is sin theta. What's our opposite? Vy. That initial velocity at which the object moves. This final velocity along the vertical component, velocity along the horizontal component. Over all this, you have hypotenuse, which is u, cross multiply, you have Vy equal to u sine theta. When you are dealing with vertical component of the velocity, in the vertical component, you use sine theta. Let this one be your memory. Vertical component, and also let's get the horizontal component. That is a horizontal component. I now use cos theta, which is cos theta equals what's our adjacent? Vx over u. When you cross multiply, you have Vx equals to u cos theta. These are our horizontal components. These two are very important. Let it be your memory. Vertical component, u sine theta, horizontal component, u cos theta. Now let's now go into first equation of motion. So V equal to u plus at. This first equation of motion. But when you are dealing with assembly to gravity, change to V equal to u plus gt. A will turn to g. But take note of this. When you throw an object up, when object moves up, is an object goes up, goes against the force of gravity, it will be minus g. And as it's moving up, the final velocity equal to 0. But when the object is coming down, your initial velocity is 0 because it's at rest, and it's plus g. Take note of this. When an object is being thrown up, it will get to a point that it rests. That's final velocity before it starts coming down. The final velocity when it rests is v equal to 0. Now, let's now see. We want to get the time to reach the maximum height. That is, it's going up. When you throw an object up, time to reach the maximum height. At that point, v equal to 0. V equal to 0 at that point, and your g is equal to minus g. Because it's going against the force of gravity. It's resisting the motion. And you now replace it. 0 equals u. Since it's going up, that's the vertical component. We are going to make use of this. U sine theta. To change this plus to minus g because it's going against the force of gravity. Minus gt. Take it to the other side. Minus gt. Turn to gt. Gt equals u sine theta divided by side by g divided by g. Let's cancel this. T equals u sine theta over g. This is time to reach maximum height. Now let's see the time of flight. Time of flight, just 2 times. It goes up and down 2 times. That's 2t, which equals to 2 u sine theta over g. Is time of flight. This is how to get an expression for the time of flight. This is the end of our class. Please subscribe to my channel so that I can get the latest video. Have a wonderful day.